Other side. Let's fill in a couple details here. Okay? So first things first, the word. Stoichiometry. Say it.
Stoichiometry.
Good. You guys are the first class that everybody said it. Good. Stoichiometry. So it's not geometry, it's stoichiometry. All right? We in first period, we all felt very like we're from Boston or something when we said like stoic. I don't know. It's kind of cool. Or is it Brooklyn? I'm not good with accents. Or that. Okay. All right. So stoichiometry, it's going to involve the mass relationships between reactants and products. This sucks. All right. In a chemical reaction. Okay? Okay. It is based on your law of conservation of what? Good. Okay. And it's always going to start with, and this is your one job in this class, okay, when we're going through this unit, it always starts with a balanced equation. Oops. A balanced equation, okay? All right, so this is stoichiometry, all right? So it's the idea that now we're going to be comparing different things, all right? And you always have to start with that balanced equation because that's where we get coefficients from. So that brings us to our mole ratio. Mole ratio is a conversion factor that relates the amount in moles of any two substances in a reaction. Okay? So what that means for you is you are comparing two characters. Okay? It also means to you that you are focusing in on those coefficients, which is why if you can't balance, you can't stoic. Yes, that's my word. Okay? All right, so since I've just given you that little piece of information, can I get a volunteer to tell me a mole ratio that they see in our example right there? Don't be scared. I just said a mole ratio is moles of any two substances. And I told you over here in the red, coefficients. So can somebody relate calcium to calcium oxide? Give it a try.
2 to 2.
Lauren said 2 to 2, and that's correct.
Hey.
Yay, Lauren. Next time, speak up. All right. Good. All right. So what I want you guys to get from that is we are just looking at the coefficients. So it's a 2 to 2 mole ratio. When we are comparing something like calcium to calcium oxide, okay? So now that she kind of knocked out the scary one, somebody give me another example.
2 to 1.
What are you defining?
Calcium to oxide.
Okay, so calcium to oxygen, I agree with that. So she's saying it's a 2 to 1 when we do calcium to oxygen, okay? Did you notice she actually just did 2 reactants? You okay with that?
Yep.
Should kind of confuse you a little bit because I just told you that you should be comparing reactants with products, but you can absolutely do that. Just like a recipe, when you go to cook something, you have 2 parts that, 3 parts this, and stuff. You can do the same thing here. So for every 2 calciums needed, 1 oxygen is needed to make calcium oxide, right? Okay, sure, 2 calcium oxide, sorry. All right, who wants to give the last one?
1 to 2.
1 to 2, what are you defining?
Oxygen to the calcium oxide.
Good, oxygen to calcium oxide. Okay, so that is a mole ratio for you, okay? Okay, So we're going to add one little thing to this. I have to draw an arrow because I can't write small enough. I apologize. You can write it right there in that little space. Okay? A mole ratio is what Miss Vogel likes to call the mole bridge. Okay? So, just like I told you, no matter what, you got to travel to Mole Town. Okay? You're going to travel to Mole Town, you always have to cross this bridge in stoichiometry. So if you come to a point where you don't have a mole-to-mole relationship, something like your coefficients related to each other, you didn't do it right. Okay? So just always remember, you're going to need that mole ratio. Okay? How are we doing? Good? Okay, so that leads us to molar mass. Okay, so molar mass, you guys should know this definition already, right? Molar mass is in what unit? Grams of 1 mole of a substance. It's a conversion factor that relates the mass of a substance to the amount in moles. Meaning it's your way to travel from grams to moles. Okay? That's all they're saying. Or back. Okay? All right, so cool. So we've got our 3 main things that we're going to be using. For stoichiometry, for your guys' purposes, you probably won't be going to particle city very much. All right? You're probably going to stick with grams and your moles. And you're just going to kind of sit there and go back and forth. Okay? Because that's more useful to us in the lab. Grams are, right? Okay. You will be held accountable for knowing your different types of reactions. So pink poster over there, orange poster on that side. Okay? So you had synthesis, decomposition, all that stuff. You will have to know those. When I say 4 types of problems, I'm talking about what types of stoichiometry are you doing. All right? So we're going to write out the 3 basic ones. The really easy one that you guys are all going to love is the mole-to-mole. Yeah, that's your one-stepper. Okay? That's me saying, okay, if I give you 3 moles of calcium, how much calcium oxide do you produce in moles? Super easy. You go straight to the mole bridge. The next type that you'll get is a mole to gram. Okay, so I can say, if I give you 3 moles of calcium, how much calcium oxide is produced in grams, right, mass-wise? Okay? Or I could turn around, here's your third type, and I could give you grams of calcium and ask you for moles of calcium oxide. Okay? So that's your third type. Your last type, which unfortunately people call it brutal. I think you're fine as long as you go down to the right. If you just bring the thing down to the right, you cross the mole bridge, down to the right, you're never going to go wrong. But people like to say this one is the brutal one, which is grams to grams. Okay? Because what you're doing is what I told you guys story-wise, where you start in Gramland, travel to Mole Town, cross the mole bridge, come back to Gramland. All right? So it's a couple steps. That'll be the last one that we learn. But all in all, you have to continue doing down to the right. Okay? Okay, put off to the side. Always cross the mole bridge. If that doesn't make sense to you, if you don't like the story, say always have a mole ratio, okay? Okay, all right, any questions over basic vocab? So we got that. All right, so let's look over our recipe or the steps for stoichiometry. So your first step is always going to be to balance the equation, okay? Like I've told you, that is going to be your guys' job. So in your notes, I have in a couple places just taken out the coefficients just because you're supposed to catch it. I will do the whole equation with you if you tell me to start with the equation. And then if we end up finding out that the answer is wrong, you're going to have to go back and start over. So it's your job to always check that reaction. Are we clear? I'm not going to do it for you ever. Cool? So you guys have to call it. The minute you see it and it doesn't look balanced, you say, called it, or you just say it's not balanced or whatever. Okay. All right. Cool. So number 2, it says identify the given chemical and measure. Anytime you see the word measure, this is supposed to be unit. Okay? I kind of took this idea from another person, so. Okay? So you're going to identify your given. Okay? That one I usually like to circle. And you need to find what you're going to be wanting, as well as its units, okay? You change your given to moles, meaning you travel to mole town, right? So we're using your molar mass to travel to mole town. Then you're going to use the balanced equation coefficients to form a ratio. This is the mole bridge step. Okay? So this step is going to look like you'll have mole on top of mole. Something compared to something else. Okay? If you don't have something that looks like that in your railroad track ever, then you did it wrong. I'm just telling you right now. Okay? All right. And then finally, change it to whatever you wanted. All right? So we're still going to start with what we want, or start with what we're given on top and end with what we want on top. So that rule is not going away. All that I did was I inserted this little step. And that's all that's changing. Okay? So you guys have conversions down for the most part. That's the only thing that's changing. Okay. Chemistry world. Yeah? Yeah? All right. So looking at chemistry world, you got 4 different places in chemistry world. All right? You've got Particle City, you got Grahamland, you got Volumeville. We aren't going to be messing too much with Volumeville, but I do want to give you a couple of details about each one. This is meant to kind of help my people who still don't get that you probably have to have a mole somewhere in your calculation. All right? Moles, if you notice, Mole Town is the center of the world. All right? Do we see that? Mole Town, you have to go to Mole Town. Like, Mole Town is the best town ever. All right? Okay, so Mole Town, and I'm not going to be able to draw very well on this, but you can draw little houses and whatever we're going to be doing. So Mole Town is like your typical little town. So we got a little bit of houses here. Okay? And they are in the center. Okay? Particle City is just like San Antonio downtown. Okay? So all these buildings and all that stuff. All right? It's a crazy place. Okay? Particle City is also known as what? What kind of stuff is in Particle City? What else do we say besides particles? Atoms, formula units, molecules, any chemistry words, all right? So just keep that in mind. So these are chem words. But if I said chem word city, it just would sound weird. So those are chem words in Particle City, all right? Okay, over in Grahamland. All right, so for Grahamland, we kind of pictured earlier like a castle. So I'm going to make a castle. Does that look like a castle? I think this is my best castle all day today.
That's really cute.
And here's my moat. There's my moat because he has to have a moat. Oh, and Princess Dana right here. I'm an angry princess. All right, there we go. All right. That's supposed to be my crown, by the way. I don't know if you caught on to that. That's my crown. That's not my hair. I have beautiful hair. Okay. All right. Okay. So we have Grahamland. All right. And in Grahamland, what are we dealing with in Grahamlands? What is this all about? Mass, right? So we're dealing with masses. Okay. And that makes sense. Okay. Volumeville. You don't know much about Volumeville, and that's okay. But what can you tell me about the units for volume usually? What do you think the units are going to be? You guys have been using, what did you say? Right, so what do you measure things in when we use our graduated cylinders in your lab? Milliliters, right? So liter is actually what we're doing. So Volumeville is all about liters. And this is going to be when you get to gases. So Volumeville sounds to me like farm. So here's my farm. That's my barn. This is so much different with an iPad. Oh, that's not supposed to be a smiley face. That's a pig. Shh, I'm not done yet. There's the tail. As long as you put the tail, then everybody knows it's a pig. All right, so there's my little thing. And since we use this in gases, this is a very gassy little ville, if you will. All right?
That's because the pigs, they fart a lot.
Yes, exactly. That's why I put a pig. All right, them and the cows. Too much methane over there. All right, so we're going to deal with that when we get to gases. So this is cool. So Miss Vogel just made you draw a bunch of pictures, right? Yeah. But the part that I need you guys to get from this is that in between all of these is an abyss. Does everybody know what an abyss is?
Yes.
Okay. It means like if you go into it, you're like gone, right? So you can't go around from Gramland to Particle City. Okay? Who do you have to travel through in order to get to any of these places? Mole Town, exactly. So if we're trying to go from Particle City to Mole Town, we have to ride on the Avogadro Express. Okay? The Avogadro Express. All right? That one costs you 6.02 times 10 to the 23rd things to ride on. Okay? Things. I don't really know what else. Particles. There you go. All right. Okay? In order to go to Gramland, okay, we have to ride on the, what do you have to do? Where do you get that information? When you're trying to go between moles and grams, what was that conversion? Molar mass. So we called it the molar mass. Since we're going to a castle, we said carriage. Okay? And you have to pay them with whatever your mass is. Okay? So we look at the periodic table for that. In order to go to Volumeville, like I said, you guys have no idea what this is yet, but we have to ride on a B20 2.4. Get that? You guys get that? You guys know what kind of, you know what kind that is? How do you get to Volumeville? Airplane, yeah, right. A bomber, but that's okay. Don't focus on that part. But we do have to fly there. Okay? There's my airplane. Leave me alone. Leave me alone. Stylus, you guys have pencils. All right. So between all these, you do have these conversions. So the point that I want you to get from this is that between any of these, you do have to go through this special mole town. Now today, we're going to take it one step further. When you are in Mole Town, there's this special place. Make a little bridge. Okay? There's a special place in Mole Town, and it's your mole bridge. Okay? So when you go to visit Mole Town, you can cross this little bridge. When you cross this bridge, you can change into whatever character you want to change into.
Mole bridge?
The mole bridge. Yeah, it's magical. So the magical mole bridge. All right? So you could start in Gramland, travel to Mole Town. I'm going to cross the bridge. I'm going to change it to a different character, and I can go back to Gramland. All right? And that's how stoichiometry works in a nutshell. Okay? So I want you to keep in mind this little process, this little map. You have to follow the map. You cannot go anywhere but the map. Are we all clear on that?
Really clever. Did you come up with this yourself?
Some of it. Mole bridge is kind of mine, yes. The rest of it, no, I kind of improvise. All right. Okay. All right. So you have a map of stoichiometry. You will always have this, okay? Let's go ahead and turn the page back to the first example. Okay, so I have some hydrogen, some oxygen, making some water. What do you want to do? Balance it. All right. So go ahead and take a second to balance it. Did you balance it?
Yeah, I think I did.
Okay, so what is your mole ratio across the whole thing? So the mole ratio means, so when I say that, you can say, since there's 3 characters, you could have said 4 to 3 to 2, if that was what it was. But that's not what it is. So what did you get for coefficients?
I balanced it, but I don't know.
What's your coefficient in front of H? 2.
2.
All right, so you have a 2. What do you have in front of your O? Nothing. So that's a 2 to 1 to, what do you have in front of H2O? 2. Okay, so when I ask, that's a 2 to 1 to 2. Okay? That's what I mean. If I ever ask you what your ratio is, or if they ask you on a test, just go across, look at all your coefficients. Don't forget that when you don't have a number, that is 1. Okay? All right. So, before we move on, also, what type of reaction is this? Synthesis. Good. We can go ahead and label that. That's fine. Okay, make sure you are still practicing those. All right, so now let's look at the problem. We've got how many moles of hydrogen are needed to produce 1.25 moles of water. So this is what we are wanting, moles of hydrogen. what we are given is right here. Biggest issue I saw on the test, by the way, is a lot of people wanted to start with the molar mass. Okay? Can't start with a molar mass. That means you're starting on the carriage. Can't start on the carriage. You got to start in Gramland. All right? So we were trying to help you out, and a lot of people like destroyed you because you tried to start with it. So make sure you always start with the weird number that we give you, I guess you could say. Okay? Never start with your molar mass. All right. So we're going to start with that. We're going to put 1.25 moles of H2O. Okay? All right. So you might be asking, why do I have to put labels on there? You got to put labels because now you're going to be switching characters. So you have to know when you're done talking about water and when you're now talking about hydrogen. So it's going to be important that you write a lot of words on these, okay? So this is where whiteboards will be your friend and lots of paper will be your friend, okay? All right, so we're going to bring words down to the right like usual. So I'm going to say moles of water. What am I going to throw on top? What do you guys want? Good, moles of H2. Awesome. Okay. All right. So we have that mole thing. So what is this guy? What's that mole relationship called? Huh? The mole bridge. Yeah, it's the mole bridge. Okay. And proper term will be mole ratio if you want to be boring. I'm just kidding. On the test, you will probably see mole ratio. So, but mole bridge is that's what that is. All right. So we're trying to relate. So we're in Mole Town, and now we're crossing the bridge. Okay. So where do we get information about our mole ratio or mole bridge? What goes in these two blanks? It's on the. Huh? Well, what is the ratio? What numbers are you pulling from to make that ratio? Yes, the coefficients. Good. Yep. I knew you had the right idea. Just get the word out. All right. So it's a 2-to-2 relationship. So we're going to put 2 H2O, 2 H2. Now this one, probably don't have to type into the calculator. Okay. It's not always going to be this easy. But if you notice, you do have a 2 over a 2, which means that equals 1. So what is our answer without having to type it in? 1.25. Good. Moles of hydrogen. Okay? All right, we're going to take a quick pause break and label this guy. All right, just so you have the different parts of this. Okay? Okay, this first number was your given. Okay, what is mole? Or grams? Or particles? What are those things called? Units, good. So you always have to have a unit. This is a label, in my opinion. Okay? You have to label your units. Who are you talking about? Okay? Okay. These two numbers were called what? Not the mole ratio. I just want what are the two numbers called specifically? Coefficients. Good. All right, so go ahead and write that. Okay, and put an arrow so that you know for the future where you got them from to your balanced equation. Okay. Now this mole thing, that I'm okay with you labeling as mole bridge or mole ratio. Okay, and I would say I'm good with that. Those are the different parts that you're going to have to know, all right? You should be looking for those. Every single stoichiometry problem will have all of those, okay? Especially that mole ratio or mole bridge. Okay, so what I'd like you guys to do is look down at number 2, okay? I want you to give it a try. I want you to give A a try.